One is what's called a dual stack deployment. In a dual stack deployment, a host can speak both IPv4 and IPv6. It communicates with an IPv4 host using IPv4 and communicates with an IPv6 host using IPv6. What this means is that the dual stack host has to have an IPv4 compatible address. Either the host has both an IPv4 and an IPv6 address, thus allowing it to speak to an IPv4 host, or it must rely on a translator, which knows how to take a v4 compatible IPv6 address and translate it to the v4 address. One possible way of ensuring compatibility of a v6 address with IPv4 is simply to embed the IPv4 address in 32 bits of the 128 that are allocated for the IPv6 address. Now, a dual stack host configuration or a v4 compatible IPv6 address solves the problem of host IP address assignment, but it doesn't solve the problem that IPv6 deployments might exist as islands. For example, multiple independent portions of the internet might deploy IPv6, but what if the middle of the network only speaks and routes IPv4? Well, the solution here is to use what's called 6-to-4 tunneling. In 6-to-4 tunneling, a v6 packet is encapsulated in a v4 packet. Now that v4 packet is routed to a particular v4 to v6 gateway corresponding to the v6 address that lies behind that gateway, and at this point, the outer layer of encapsulation can be stripped and the v6 packet can be sent to its destination. This, of course, requires the gateways at the boundaries between the v4 and v6 networks to perform encapsulation of the packet as it enters the v4 only part of the network and decapsulation as the packet enters the v6 island where the destination host resides.